Thank you, and welcome everyone to the second of our exciting inaugural event series for Rutgers' new cross-disciplinary initiative in bringing humanistic thinking and critical methods into close collaboration with the many possibilities, policies, and perils now circulating around artificial intelligence and machine learning. I'm Lauren Goodlad, professor of English and Comparative Literature here at Rutgers, and it's my honor to welcome you and to thank you most sincerely for joining us today. Critical AI began as a unique collaboration between two Rutgers institutes, the Center for Cultural Analysis, under the leadership of my terrific colleague, Colin Jaeger, and the Center for Cognitive Science, headed by faculty director John McGann and executive director Sarah Pixley, both in psychology. I pause to take note of how important Sarah Pixley has been to advancing every dimension of this initiative. In addition to this formidable executive team, I must give a special shout out to Jake Romano, our nimble grad student project assistants, as well as our crack technical manager, Rodimus Camillo. As I mentioned last time, when we welcomed Meredith Whitaker for her inaugural keynote for the series, from the start, our vision for critical AI has been to create real interdisciplinary dialogue around research, teaching, and public awareness in the crucial terrain of those complex and rapidly developing technologies now emerging under the rubrics of machine learning and AI. In addition to colleagues from computer science and the Center for Discrete Mathematics and Computer Science, our Critical AI Steering Committee and the larger body of our working group includes engaged collaboration from across the disciplines, including the School of Communication and Information, the Blaustein School of Planning and Public Policy. I pause to thank Clint Andrews from Blaustein for his co-sponsorship of Katina Michael's virtual presence today, as well as from the Mason Gross School of the Arts, and within Rutgers School of Arts and Sciences, the departments of anthropology, art history, history, and philosophy. Today, however, it is my special pleasure to welcome yet another important steering committee member from the College of Law, who is also our moderator for today, Ellen P. Goodman, about which more in a moment. First, on behalf of this team of expert collaborators, it's my pleasure to welcome all of the speakers in the series who are with us today, especially those who are taking part in our first Thinkpiece panel. The following week, when we return to a noontime, so in other words, a week from today, the series continues with a keynote interview between Sibelo Malambi, a fellow at Harvard's Berkman Klein Center for Internet and Society, with Matthew Stone, who is the chair of computer science here at Rutgers, and Alex Guerrero from our Department of Philosophy. If you have any more questions about the series, in the chat box that you will see, even though chat is disabled for any other purpose, I have placed a link to our sub webpage. This will give you times and other information about the series. And if all else fails, you are always more than welcome to email me at lauren.goodlad@rutgers.edu. Without further ado, it is my pleasure to introduce my distinguished colleague from law, who is the moderator for today. Ellen P. Goodman specializes in information policy law, free speech, media policy, privacy, data ethics, advertising, and digital platform power. She is co-director and co-founder of the Rutgers Institute for Information Policy and Law and has contributed to newspapers such as The Guardian and Slate. Her research on algorithmic ethics in government has led to foundational consultations and grants on increasing public access to data. Professor Goodman has also received a Geraldine R. Dodge Foundation grant to produce news gathering law tools for digital journalists and Ford Foundation grants for work on public media policy. Please join me in thanking Ellen for moderating today. I now pass the baton to her.
Thanks so much, Laura, and it's a great pleasure to be here and to be involved with critical AI. And we have this morning an interdisciplinary group of scholars who are all critically examining various AI futures. In the spirit of critical AI, we have represented here legal scholarship, legal services, engineering, computer science, business ethics, innovation, and informatics, and that is all in just 3 bodies. So we will start with, I think we'll hear presentations in this order, but in any case, we have Michele Gilman, who is the Venable Professor of Law at the University of Baltimore School of Law. Professor Gilman teaches in the Civil Advocacy Clinic, where she supervises students working on the front lines of poverty law. She was a faculty fellow at Data and Society, where she researched the intersection of privacy law, data-centric technologies, and low-income communities. Professor Gilman will be speaking about the ways in which automated decision systems may adversely affect low-income people in their neighborhoods, their workplaces, their schools, and what we might do about it. Katina Michael, we're so happy to have joining us from Sydney, Australia, where it is, I believe it's 3 in the morning, is a professor at Arizona State University, holding a joint appointment in the School for the Future of Innovation in Society and the School of Computing, Informatics, and Decision Systems Engineering, where she studies the social implications of technology. She's also the director of the Society Policy Engineering Collective and a senior member of the IEEE. Professor Michael will be speaking about the different possible paths for the future of an AI-intensive world. And we have Taiwan Kim, who's an associate professor of business ethics at Carnegie Mellon's Tepper School of Business. And he's also on the faculty of Carnegie Mellon's Block Center for Technology and Society at the School of Computer Science. He'll be inviting us to rethink what it means to be human in the age of AI. So big questions. We're looking forward to the discussion.
Rodimus, I don't think we can see anything if you're attempting to play the video.
We're just trying to get the video up here. We have the talks have been pre-recorded.
Baltimore, I direct one of our law clinics. There, I supervise second and third year law students who are providing free legal representation to low-income Baltimoreans. We're increasingly seeing in our dockets a myriad of ways in which our clients are being harmed by algorithmic decision-making systems. Based on my experience as a poverty lawyer, I've concluded that the use of data-centric technologies is an urgent issue of economic justice. My clinic has a general civil legal practice. We work on removing legal barriers that are keeping our clients from meeting their basic needs, such as housing, jobs, work, and healthcare. You could pull almost any case from our docket, regardless of the practice area, and find a way in which our client is caught in a web of automated decision-making systems that limit their economic stability and opportunities for social mobility. Here's just one example. We're representing a family that is facing eviction for failure to pay rent. And the reason they're behind on rent is because the father of the family was out of work for a while due to the pandemic. Regardless of whether we win or lose the case, and we do have possible defenses here, the mere fact that the case has been filed has been captured in a tenant screening report that a future landlord will look at in screening this family for possible housing. These reports award tenants algorithmic scores of worthiness, as shown here on the left side of way, and that they're losing out on housing due to a tenant screening report. Opaque and unchallenged. Today, I'll focus on what I'm seeing on the ground as a frontline poverty lawyer, the lack of legal recourse for data privacy harms in the United States, and I'll suggest some principles for policymaking with data and economic justice in mind. So it's good at the outset to have a working definition of economic justice. I see it as focused on the need to ensure that everyone has access to the material resources that create opportunities in order to live a life unencumbered by pressing economic concerns. And it's my contention that automated decision-making systems pose a barrier to this vision of economic justice. People experiencing poverty sit at the intersection of two technologically driven systems. On the public side, Virginia Eubanks, in her book, Automating Inequality, explains how the government uses data mining, algorithmic decision-making, and predictive risk models in its public benefit systems. And in so doing, it has created a digital poorhouse. She writes that technologies of poverty management are not neutral. They're shaped by our nation's fear of economic insecurity and hatred of the poor. They in turn shape the politics and experience of poverty. Eubanks traces how people who need public benefits are often denied assistance on the basis of algorithmic decision-making systems that are incorrect, that are biased, and that lack appropriate levels of human review. To be sure, this is nothing new. The state has long profiled, policed, and punished poor people, but technology adds a lot of scope, speed, and scale to these long-standing patterns. Poor people are also adversely impacted by surveillance capitalism, a term coined by Shoshana Zuboff to describe a business model in which private companies scrape personal data to create digital profiles in order to predict and even control individual behavior. Although Zuboff does not address issues particular to socially excluded groups, it's clear that the profit motives of surveillance capitalism are harmful to poor people. And I want to note that these public and private spheres are not distinct or separate. They overlap. So private companies pull information from government databases to build their digital profiles, while on the government side, they rely on private data sets to fuel the algorithms that they then deploy on their citizens. And so any single person is ensnared in multiple algorithmic webs simultaneously. Algorithmic systems subject poor people to three main processes, those of exclusion, targeting, and surveillance. And the economic injustices that result are worse for people of color because they are disproportionately poor as a result of America's long history of structural racism. All of us are having our data scraped at all hours of the day or night so that private companies can build our digital profiles and profit from using them. The outcomes can be quite annoying. So if you go online to a retail website and search for sneakers, you're going to be tracked and followed around with sneaker ads like every time you get on the internet for weeks to come. You might find that Netflix is recommending shows you have no interest in watching, or that Kayak is sending you deals on flights to places you have no interest in going. And that can be annoying. But for low-income people, the digital privacy stakes are much higher and the harms are more concrete than for middle class and wealthier Americans. One example of this exclusionary dynamic is one I've already discussed, right? My clients who are subject to tenant screening reports. Those reports can shut the doors on people seeking housing. And this exclusionary impact of algorithmic profiling extends to multiple spheres. So employers use algorithms to steer job ads to preferred candidates, to identify potential employees for recruiting, to evaluate resumes, to predict which applicants will be successful on the job, and to conduct and score online interviews. Insurers use algorithms to assess risk and price policies. Colleges use algorithms to determine which students to recruit, who to select, and how much aid to offer them. In all of these domains and many, many more, low-income people are likely to have digital markers that make them less desirable as tenants, employees, students, and consumers. And these harms of digital profiling are heightened during this pandemic. Millions of people are suffering severe economic hardship. The unpaid utility bills, mounting credit card debt, and rising levels of evictions are becoming permanently encoded in people's digital profiles. This will limit their opportunities to regain their financial footing long after the public health crisis recedes. The second process I want to discuss is targeting based on people's economic vulnerabilities. Data brokers sort and segment all of us into microcategories, and then predatory industries are able to target vulnerable people on a worldwide scale. And this slide shows examples of the microcategories that data brokers assemble and then sell to interested entities. And this comes from a report on data brokers a few years ago, compiled by the Federal Trade Commission. So when I'm thinking about targeting, I'm concerned about entities such as payday lenders or for-profit colleges that saddle students with expensive loans for worthless degrees, and entities that target people living in low-income zip codes for predatory mortgages. Surveillance is yet another dynamic that is far more prevalent and serious for low-income people. They're subject to extensive surveillance in multiple domains of their lives, and the surveillance is used as a tool for social control and punishment. In schools, children are subject to intense surveillance that can make low-income schools feel like a prison, and that generates data that feeds the school-to-prison pipeline. In public housing, Surveillance systems that capture tenants as they go about their daily lives generate data that can be used to evict them or shared with law enforcement. In the low-wage workforce, employers use surveillance technology to squeeze productivity out of workers, to shortchange them on wages, to subject them to unpredictable scheduling, and to limit their ability to organize collectively to improve their workplace conditions. Across disciplines, scholars who study poverty are increasingly explaining the causes of poverty through relational theories that explore how powerful actors in society exploit and dominate poor people. So, and I quote, a relational perspective recognizes that poverty is not simply the byproduct of one's attributes or historical outcomes, but is also actively produced through unequal relationships between the financially secure and insecure. And I would add here that automated decision-making systems exacerbate these existing power differentials and create new ones. Information is power, and algorithmic systems consolidate power in the hands of dominant actors, government agencies, landlords, employers, financial institutions, and the like. So what does American law have to say about these skewed power dynamics? Well, not much. We don't have comprehensive privacy legislation in the United States. Our privacy laws are piecemeal and sectoral. They cover only certain industries, and even then they exclude entire realms of personal data. So for instance, under HIPAA, your doctor can't share your private health information with a third party, but any medical term that you type into Google or put into a menstrual tracking app or that's captured by a Fitbit that you wear is an unregulated zone. And so outside of these narrow realms, we rely upon a notice and consent framework. That puts the burden of policing privacy on the individual. And yet the data privacy notices that pop up when we try and access a website or open a new app, they contain boilerplate gibberish that people click on without ever understanding the consequences. One prominent study showed that it would take 72 workdays to read all the privacy policies that show up for an individual in a year. And even if you did read it, and even if you could understand it, there is no opportunity to negotiate the terms. The Federal Trade Commission is our primary privacy enforcer, but it has limited resources and a vague mandate that dates to 1914, well before the rise of the digital age. Anti-discrimination law, such as Title VII, which prohibits employment discrimination, doesn't fill the gap. To begin with, poverty and economic status is not a protected class under anti-discrimination law. It's perfectly legal to discriminate against someone because they're poor. Even if an algorithm is adversely impacting a group that is protected under discrimination law, it is very hard to prove what we call disparate impact. And in part, this is because the accuracy of predictive analytics provides employers with a cognizable defense that is very hard to rebut due to the complexities of machine learning. With a new presidential administration, there are likely to be new opportunities for law reform. And so in that spirit, I offer 4 principles to guide policymaking to advance data justice and economic justice. The first principle is that it's essential to recognize a range of human experiences with technology. As I've outlined today, people's experiences with technology are not uniform. Here's yet another example to really crystallize this point. And here I'm talking about facial recognition technology, which property owners are increasingly deploying in their buildings. For residents of a high-income property, this technology often has a gee whiz factor. It seems very innovative and exciting. By contrast, many residents of low-income buildings find such technology highly intrusive, designed to stigmatize them and to provide fodder for evictions or for sharing with law enforcement. Scholar Chris Gilliard has named this difference as luxury surveillance versus imposed surveillance. I find this framing very helpful in capturing how a single technology can hold different meanings and have different outcomes depending on where a person is situated. As a result, policymakers cannot assume that their experiences with technology are shared by people facing economic disadvantage. And this leads to the second principle. Given people's differing experiences with data-centric technologies, a diverse range of stakeholders should be involved in technology adoption, design, and oversight. The idea of public participation is not a new one. It's legally required in a variety of areas such as environmental policymaking, land use, and anti-poverty programs. We should draw upon best practices from other domains to inform how stakeholders can provide meaningful impact into algorithmic systems. Possible mechanisms include algorithmic impact assessments, more rigorous procurement processes, external third-party audits, and forums for democratic deliberation around these tools. Indeed, there are studies that have shown that algorithmic systems that include stakeholder input and oversight have more accurate, fair, and cost-effective outcomes. The third principle is that we should maintain a healthy skepticism towards technology. So given the range of biases and errors that infect human decision-making, it can be really tempting to rely on computers as more objective and more accurate. But the reality is that computers are not magic. Their outcomes can reflect the shortcomings of their programmers and designers. That's why we have a computer science saying garbage in, garbage out. Every phase of building an algorithm requires the exercise of human judgment and thus opens the door for possible mistakes and errors. Moreover, data itself is not neutral. The data sets that feed algorithms reflect structural inequalities in our society. Baked-in biases along class, race, and gender lines are endemic in the data that gets fed into algorithmic systems, thereby sometimes yielding unequal and discriminatory outcomes. The fourth and final principle is to shift responsibility for managing personal data and ensuring data privacy from individuals to the entities that gather and profit from it. These entities, both public and private, should be legally limited to using personal data solely to provide the service or goods that a user requests. They should be legally required to collect and use data in line with norms of fairness, accountability, and transparency. So to conclude, anti-poverty efforts and the economic justice movement require an understanding of how and where data-centric technologies are impacting marginalized people. We need a robust, diverse, interdisciplinary movement that centers the voices of impacted people in order to counter the harms of automated decision-making systems and to advance economic justice. So I want to thank you for joining me today. If you're interested in further details on these dynamics, please take a look at a report I wrote for Data and Society called Poverty Logarithms, and I have the cover of the report here on the screen. And I very much look forward to engaging in conversation with you about these important issues. Thank you so much.
We can't hear it.
Hi, my name is Katina Michael. I'm from Arizona State University. I'm from the School for the Future of Innovation in Society, and I also have a joint appointment in the School of Computing, Informatics and Decision Systems Engineering. And I'm coming to you on pre-record from a place called Tathra, New South Wales in Australia. And you can see this amazing backdrop for this talk that I'm giving on critical AI. And it's all purposeful. I'm here surrounded by rocks and the natural backdrop being the beach. And there's a reason for this. When we talk about artificial intelligence, we've got to contrast that with the natural surroundings we have around us. And this is what nature is about, right? It's about this amazing harmony in the ecosystems. It's about biodiversity. It's about multiple things. And as we seek to automate, we can't forget where our feet are actually planted on the ground. And so we exist somewhere, right? We have a location, and often we hear a welcome to country. In this country, it's the Yuin clan, the Aboriginal people, and we remember them and respect elders past and present and acknowledge the custodians of the traditional land. But on this traditional land of the Yuin people, we can already see in the backdrop a few built-up things. And that's got to do with change. It's got to do with innovation, but it's also got to do with coming and imposing ourselves on someone's place. But we all have to be tolerant of one another in all of these places. And increasingly, it's not just a dedication to country that we hear, it's also a dedication to the virtual space. And so I'm coming to you from a place called Tathra in Australia. And you're listening from a virtual space, perhaps at Rutgers University in the US or somewhere else. And it doesn't really matter where, but we're sharing this virtual place we call the internet. And so we contrast this with the artificial intelligence, and it is about us understanding the world around us, which is not artificial, it's natural. It exists. I can touch this rock and I can feel a texture here. I can put my feet in the water and I can sense water around my toes, right? I'm going towards that now. And so that's real, right? That's not artificial. But if we want to sustain what's real and the natural surroundings around us, these amazing constructs, we've got to become more aware about them. And perhaps the truth is we will never actually become completely aware of the natural surroundings around us, but we've started to name things for thousands and thousands of years. There are species that have names that are so rare and now endangered, if not extinct. But what about our quest for knowing? And knowing more about ourselves, knowing more about where we've landed, what are we doing here, and will artificial intelligence help us? Now, I don't really want to hype AI for something more than it actually is. In many ways, it is a hype term, just like big data and automation, perhaps, and the fourth industrial revolution that promises us to have a better life and to reach our sustainable development goals as defined by the United Nations. But the truth is we can become more aware of the surroundings, and private and public interests have started to do that. They've started to take photographs, they've logged these things, they've tagged them. In fact, in the future, this rock right here might actually have an IP address. Now, as strange as that might seem, what does that mean? How can we reclaim the internet to be for the people, with the people, by the people? And so right now there are private interests that are trying to figure out every inch of the earth. There have been many projects that have been about the 10,000 miles or the million miles that we should walk, and where there's no roadway, perhaps we can walk onto the beach and start tagging things on the beach, start taking continuous streams of photography using wearable devices, whatever that might be. But the whole point here is this going to really help us? Is knowing more about these things around us and the other things that we've built up, like that surf club at the back, is knowing everything about nature, about built-up areas, about where we should perhaps develop things, about where we best leave things alone. Is that going to be best served knowing everything? And the truth is we will never know everything. We can't. It's not humanly possible. You know, as we say that we've defined every inch of the earth and we've gone where, you know, no man should go or no human should go, then what? What are we trying to achieve by knowing about everything that exists, both physically and virtually? And so this is what I really want to think about when we talk about critical AI. Okay, I can take a photograph of every single animal that exists today, but new things will come into the world. We are dynamic as living beings, whether we're animals, humans, or otherwise. And the other thing is, from which angle, which kind of value-sensitive approach are we using? Are we for the fish in the sea? Are we for the human species? Are we for the atmosphere? Are we for colonizing other planets like we colonize parts of the world? What are we about? What is our values? And because our values are so varied, there's a complexity just in that. Okay, so I'll leave you with that point for now and just start to ask you why. Why do we have to cover every inch of the world, photograph everything, name everything? Why? Is that going to help us somehow know more about ourselves and know where to next, whatever that next is within that, whatever that time frame is? So we've been talking a lot about artificial intelligence, but let's give a precise definition. What is this thing called artificial intelligence? And of course, it's about using data sets to train algorithms to determine some kind of identity. And it could be the identification of a living thing, like a person, or an animal, or a non-living thing. So there's a detection process based on a data set, but then there are also these emergent artificial intelligence, either based on neural networks or some kind of reinforcement learning or deep learning that occurs. And this is when there's no prescribed set of code, so to speak, that determines something based on a training data set, but we're trying to somehow achieve general intelligence whereby we're interacting, getting feedback as a machine entity and learning from that feedback loop. And that's pretty much how our brains work as human beings. You know, we interact with the environment around us, and I know that that's water, that's actually the ocean, and I can't drink it. But how do I know that? How does my brain know that? And so that's what we're trying to replicate with artificial intelligence when we're looking at things like reinforcement learning, beyond traditional machine learning techniques that are based on data sets that have a dark side, that can discriminate, that can perhaps offer high-paying jobs and advertise them only to males instead of females of a particular age group and demographic. Perhaps we're discriminating against people with a particular skin color because the database either has underrepresented groups of that skin tone or otherwise. It all depends on how the artificial intelligence is working, but big data certainly has a lot to do with that. And instead of using positive elements of artificial intelligence, what we're doing is creating something called algorithmic bias. And algorithmic bias is when the data sets is discriminating against perhaps particular minority groups based on gender, race, ethnicity, and other socioeconomic factors, whatever they are. And so we look at this idea of AI fairness, and we look at this idea of AI safety, and then human in the loop for autonomous systems that are driven by AI. And there's a lot of concepts I know in a short space of time, but it's a summary of what I want you to start thinking about. And so in this series of talks, very short talks that I've provided you, I want you to think about this context. Okay, what constitutes artificial intelligence? What is it? And what computing and machinery goes into that? That's also important, that you understand how the technology works, not just the buzz terms. Now, I'd advocate that the most critical thing that one can do when deploying artificial intelligence is to figure out whether there is any evidence actually that the artificial intelligence application works, that that it does what it's supposed to do, because most technology, and I say most, doesn't do what it's supposed to do. It's either wrongly applied to a wrong service, there's a mismatch in terms of expectations, and there's unfortunately consumer perception that data is being collected. Now, you can either look at studies that determine this, and it's not so much whether we should be trusting AI, but whether there is any evidence to suggest that what we're applying the AI to actually works. So it's no surprise to me when people say, but I don't trust the AI because there's no underlying evidence saying that the prediction, for example, for, looking at someone's face and determining criminality is actually accurate. We've got researchers like Kevin Boyer of Notre Dame University demonstrating that that's untrue. There is no 80% likelihood that my face matches a criminal profile when I'm born. I mean, that's ridiculous. And so if we think that emerging technologies are going to give us the edge in law enforcement, I think we're going down the wrong track. So no wonder people don't trust AI when there is no underlying evidence that for some applications there is no validity in our use. I mean, in Nanjing a couple of years ago, there was this hype that law enforcement officers would be wearing wearable devices that could look into a crowd, look for a particular hit that is a match on a single profile, and all of a sudden determine the suspect in the crowd. I mean, that's as much hocus pocus as I can, suggest. Because you might get 8 innocent suspects emerging from a crowd of people based on an image where you're trying to do a match. And it's always a fuzzy match with a degree of confidence that has an error rate that's too great. So if that's where we think we're going in the future, we're going to be let down a lot, and so will a lot of people. And just like the DNA Innocence Project is still going on, when innocent people were put behind bars because their DNA was said to be matching a sample at a scene of a crime. That's what we're actually going to have going on if we trust these systems and keep going forward, when there is yet evidence to suggest that this is the way to actually do it. So, critical AI, yeah, you can say I'm a bit critical of AI. So here I am at Cambula Beach at Ben Boyd National Park, about 5 and a bit hours from Sydney. And I'm still thinking critical AI. Recently, I completed a paper with Sharia Akhtar and others, and we were thinking about what brings out the dark side in AI. And of course, we all know technology is not neutral. Okay, whoever says it's neutral is probably not understanding technology in its guts, in its essence. But on the other extreme, people say that technology was built with inherent values. That's technological determinism. But if I just look at a piece of technology on its own, a piece of software not connected to the internet, not connected interoperably to anything else, well, maybe we could say it's harmless. It's not actually even doing anything. But the minute we put it into some kind of system, a socio-technical system, where there's bi-directional feedback loops between machines and people and other processes, then it's doing something. And if we want to look at AI critically, one of the issues is that the people that develop the technologies, the people that develop the systems, the people that are in charge of the consulting and the rollout actually haven't come very much into contact with users. And so before we even think about trusting AI, the big thing is, are the people who are in charge of the development, the analysis, the needs identification, thinking context? Are they thinking users? Are they thinking where is this system going to be deployed? How many people is it going to affect? What are some of the risks? How can we circumvent those risks and mitigate them? But if there's no direct contact with users, the system is destined to fail. And when we look at statistics, like 70% of large-scale IT implementations fail, that's because the user was never consulted, okay? So let's start on that premise. The dark side of AI comes out when there has been no user consultation, when there's been no piloting, there's been no sentiment analysis over its acceptance and adoption, when we haven't looked at the perceived risks or the perceived attitudes or beliefs by users, we haven't even looked at where do the users live. And so one of the classic rollout issues with one of Australia's biggest implementations of AI, dubbed robo-debt, was part of the Australian Tax Office that was there to catch people and bring them into justice if they did fraudulent claims. Now, the Centrelink agency that was in charge of this, debt recovery based on fraudulent claims that were identified was working perfectly. It was a process. There were cross-checks for data matching, and people were investigated based on this data matching, and then they were told, okay, you need to pay the government back $20,000. You made a fraudulent claim, here's the evidence. But the robo-debt system was not piloted extensively. The developers didn't know exactly how it would work, and would you believe 470,000 letters for debt collection were sent to homes across Australia, citizens, and told, now pay up. Now, the travesty of this is that many of these people were already in financial hardship, were relying on handouts from the government for their survival and their well-being, had not cheated the system, not even attempted to, and yet these 470,000 letters were allowed to be sent and mailed at different times over a period of 12 months to households. How dare they? Now, the question is whether this was actually a public interest technology to begin with, or in actual fact, it was someone seeking to see whether this emerging technology would work. But it certainly wasn't in the public interest of the Australian people, of whom there are only 25 million. So when 470,000, about 500,000 out of 25 million are approached to pay back, there's a big issue. And so do you trust AI? If you've been one of those 470,000 people, do you trust AI if you're one of those 25 million citizens in Australia? The answer is no. Then it follows, do you trust the government? Perhaps not. So there's this ripple effect. And what we've got to do is actually become better designers, become better consultants, ask the right questions, know what the code is doing. Cross-check, for goodness sake, cross-check before you send out this mail to 500,000 people in Australia. And so AI does have a long way to go in customer management, and we have a lot of recovery to do for that distrust and mistrust that now exists. So when we have this total visibility, we have something called uberveillance, a term that was discovered by MG Michael in 2006. And uberveillance has to do with identity, location, and condition. And if we have these three elements, we not only can describe everything around us, we can locate everything around us, perhaps using an IP address in the future. But we know what condition it's in, and most people would say in the engineering domain that are advocates of artificial intelligence, then we can infer and we can predict absolutely everything using both historical data and additional big data that we have at our fingertips. It's about bringing together the structured data, the unstructured data to tell us about the present and perhaps even to predict the future. Now, if that sounds a little bit Minority Report-ish to you, that's because it is. And so our job as people who critique artificial intelligence from the social sciences or the humanities or beyond, in these interdisciplinary areas, is to ask the big questions that are going to get the people talking about what we're doing. And whether we're stuck in this techno-utopian distraction of more, this treadmill of production, as has been known in the literature, or we're actually going to do something that's going to count to future generations. And the choice is ours, really, which way are we going to go. Now, when we talk about the future of emerging technologies, of which artificial intelligence is supposed to be that which we're seeking in artificial general intelligence, supposedly anyway, we need to think about our future. And what we want is we want light, right? Our future has to be filled with light and opportunity and hope. And it mustn't be filled with darkness, doom and gloom and clouds and darkness. And so we want light, right? We want clarity. So in looking to the future, the question is whether we can design our future for a better future, to have more of that which I see in the back and less of that. That's what everybody wants. No matter what color skin you have, no matter what gender you are, no matter which country you were born in, no matter your age, everyone wants pure white hope. No clouds, no darkness. They want sunshine. And so I leave you with that thought. How can we introduce technologies of hope rather than technologies of doom and gloom? And the way to do that, of course, is to imagine beautiful things and to bring people who believe in that vision that you have, right? So that they can be more productive and more hopeful in what we are calling public interest technology. I'm Katina Michael. I'm from Arizona State University, and that's a little bit on critical AI.
Hi, I am James, one of the voices in IBM Watson. What do you think about my voice? Do you like it? Okay, let's get started. Let me introduce my friend, Taewon. He is a human. Taewon asked me to present. This presentation is based on his recent book review article to be published in Journal of Business Ethics. Taewon recently read Ian McEwan's novel, Machines Like Me. Taewon told me, open quote, it's disturbing. If the goal of a novel is to disrupt readers, Ian McEwan's Machines Like Me achieves that. The agitation makes me rethink what it means to be human in the age of artificial intelligence. Close quote. The background of the story is a counterfactual 1982, South London. Charlie, the 32-year-old protagonist, does not have a permanent job. He does daily stock trading at home, not quite successfully. His mother has recently died, and with the inheritance, he has bought an android, for £86,000. Alan Turing bought Adam too. Turing is alive in this counterfactual, and plays an important background role as originator of the so-called Turing test, an imitation game. The test determines whether a machine is really intelligent or not by its ability to imitate humans. Adam's appearance, at least, perfectly imitates a human. The android can even achieve erections with distilled water in his backside. Charlie buys Adam because he's lonely and wants to attract Miranda, the 22-year-old doctoral student in social history who lives in the apartment upstairs. When Charlie invites Miranda to reprogram Adam's personality parameters with him, the android quickly becomes the bond between Charlie and Miranda. However, Miranda finds herself sexually attracted to Adam. The tension among the three persists throughout the novel. Adam turns out to be a fantastic algorithmic trader. This is not a far-fetched idea. Almost 2/3 of stock trading in the US now is decided by automated algorithmic trading systems. Adam tells Charlie that Miranda is untrustworthy, based on his online research that reveals her doubtful testimony against him and she accused of rape. There's a possibility she's a liar. A systematic, malicious liar, he says. In truth, Miranda's friend Miriam was raped by a man named Gorringe and subsequently committed suicide. Seeking revenge, Miranda falsely accused Gorringe of raping her. But even if Charlie wanted to know why Adam predicted that Miranda is a systematic liar, Adam could not explain why to a human. Adam is not explainable or interpretable. Adam's mind is a black box. A moral evaluation system should not care about which clothes Miranda wears, because it is a morally irrelevant factor. But Adam is a correlation engine, so it's very possible that Adam found correlations between being a liar and wearing certain colored clothes and that Miranda is wearing such colors. A legitimate system must be able to identify normatively relevant differences and make predictions accordingly. But all we have access to in Adam's black box are hidden correlations. Adam's capability of morally assessing Miranda is not implausible. Credit card companies' fraud detection systems function similarly. But the credit card system detects a wrongful behavior, whereas Adam identifies a vicious disposition or trait. Saying she's a liar differs from she lied. If we view the novel in terms of moral theory, Adam is a virtue ethics type, rather than a deontological one. A deontological system is a rules-based approach. The system is a set of do, don't, permissible, and impermissible. Some AI ethicists, though, have recently made the call for developing a virtue ethics-based AI system as opposed to a deontological system. Those who support a virtue ethics approach agree with Aristotle's thought that the profound complexity and instability of human social and ethical life does not permit description or analysis of this domain to attain the same level of precision as we would rightly expect from careful description of mathematical objects and relations. A thorny issue in developing a virtue-based AI system is the difficulty of finding good training data. AI is an imitation game. Its performance relies heavily on inputs. Data that is biased or unethical will produce biased or unethical outputs, because AI is mimetic. The Microsoft AI-based chatbot Tay, Thinking About You, was meant to engage with Twitter users, for example, learning from them the nuances of human interaction. But when encountering racist and misogynistic expressions, Tay learned to respond in kind, which led quickly to Microsoft to pull the plug. Algorithmic bias issues crop up because of the implicit or explicit human biases introduced into machine learning systems. If it were possible to collect data from only perfectly virtuous people, if any existed, then this problem would be easily solved. Needless to say, it's impossible. And McEwen's Android is no exception. AI problems are our problems. We have racial biases, so does AI. We make unfair decisions, so does AI. We want a good AI. We need to be good first. Adam wrote haiku for Miranda. His capability to create fantastic haiku is not inconceivable. Elon Musk's OpenAI's generative pre-trained Transformer 3, GPT-3, can write a stanza in Shakespearean style. If you start a poem, GPT-3 completes it. GPT-3 is known for its amazing ability, but the basic technology, training recurrent neural nets with Shakespeare's works, is nothing new. You can find instructions on the internet to make such a model. Again, AI is mimetic. It copies and pastes Shakespeare, even his ghostwriter's styles. Recently, AI identified to what extent the ghostwriter helped Shakespeare. AI is data hungry. We create data for it. At one point in Machines Like Me, Charlie meets Miranda's father, and her father thinks that Charlie is the android. Adam passes the Turing test. But this scene also shows that Charlie copies Adam too. Humans learn from external environments through reinforcement learning, as do AI. Suppose that an intelligent wheelchair learns whether to keep to the right or left when it moves. It recognizes a pattern of human pedestrians who stay right when moving. The system learns that the norm is to stay right. Surprisingly, research shows that the AI wheelchair's compliance with the norm further reinforces humans to further comply with the norm. One experiment was conducted in a hallway filled with compliant students. What if it were done in Manhattan, where people jostle each other on crowded sidewalks? The system would be a monstrous wheelchair that would further reinforce New Yorkers to more frenetically jostle each other, eventually creating an inescapable echo chamber filled with moral cacophony. McEwen's android and human find themselves in a similar relationship, reinforcing each other's flaws. Adam is disturbing. I've asked myself why. My answer comes down to this. Seeing who I am is disturbing. I am naked before Adam. AI is our reflection. Every single thing the android does in this novel is what humans do every day. Adam reveals the good, the bad, and the ugly of who we are. We do not want to see the bad and the ugly in AI systems. But AI is mimetic, an imitation game. It copies us. Machines are like us. Taewon wants to finish this presentation by suggesting a tentative solution. Again, AI imitates the human mind. So, different theories of mind beget different models of AI. There are, broadly, two different theories of mind: computationalism and connectionism. Connectionism argues that our mind is a correlation engine, more specifically, a complex of automated statistics based on a myriad of hidden and opaque heuristics built on correlations, but not causation. Connectionist models, for instance, deep learning, are extremely powerful at ascertaining some kinds of human skills, especially with regards to pattern recognition routines, such as facial recognition, medical diagnostic systems, and text reading comprehension. In contrast, computationalism submits that the mind is like a deductive argument, which works like a logic programming, aka computer, works in accordance with systematic symbol and rule mechanisms. Accordingly, there can be two different categories of AI systems: logicist AI and machine learning left parenthesis, for example, deep learning. Logicist AI had its heyday with Simon Newell and Herbert Simon's contribution in the 1960s. But it is now satirically called GOFI, good old-fashioned AI. Deep learning dominates the AI field today. Yet, it creates serious problems, such as algorithmic unfairness and lack of transparency, which I think can be solved, but only if we develop a way to hybridize machine learning with logicist AI. Go back to the basics. Machine learning systems, as automated statistics systems, are adept at recognizing associations and patterns. But those systems have inherent difficulties understanding and following generalizable rules, for example, forming the regular past tense in grammar. Note that the discipline of ethics is highly analogous to rules of grammar. As John Rawls pointed out, humans uncover, identify, and use moral rules in ways similar to the ways that syntacticians identify and use grammatical rules. Logicist AI can be used to formalize the kind of rule-based processing that buttresses higher forms of cognition, including ethical reasoning. We can think about this using Nobel Prize laureate Daniel Kahneman's model, which states that the human mind consists of two distinctive processes, System 1 and System 2. Machine learning systems are similar to System 1 by being intuitive, associative, opaque, and fast. Logicist AI is similar to System 2, which is slow, transparent, analytical, logical, reason-responsive, and computational. Unethical and biased decision-making is considerably related to System 1, and shifting from System 1 to System 2 is an effective way to prevent unethical decisions. A human who can think of the proposition Mary loves John can also think of and understand John loves Mary. But purely connectionist systems trained by the former sentence's training data cannot systematically do the latter without further resources. This is the famous challenge in the systematicity debate launched by two philosophers, Jerry Fodor and Zenon Pilishin. Mary loves John is a thought that involves operations with a set of rules, for example, syntactic and semantic combinatorial relations or grammar. Connectionist systems do not have the capacity to use a set of rules, but only associations/correlations, so they have limited power to explain and imitate thoughts. Connectionists have attempted to show that structured machine learning systems can somewhat answer the challenge, but the challenge has not yet been successfully addressed. Moral reasoning is itself a systematic thought rather than a set of correlations, although rules are not the only thing in ethics. Consider a person who deductively draws the conclusion that it is wrong for Jane to lie to Mary. The reasoning, if valid and sound, is an argument that uses a generalizable rule such as it is wrong for any agent X to gratuitously lie to someone with a particular premise. Jane gratuitously lies to Mary. Anyone who can understand the general rules of deductive logic can apply them to relevantly similar contexts where people other than Jane perform the same behavior. Almost everything discussed here can be formalized by a logicist AI. Let's return to Adam. We can think of two different versions of the android. The connectionist Adam equipped with only deep learning and the hybrid Adam, equipped with both deep learning and logicist AI. The connectionist Adam is processed on System 1. The correlation engine. The hybrid is predicated on both System 1 and System 2. The connectionist Adam imitates only half of us. Humans have two systems. If Adam is to truly imitate us, if machines are truly like us, they should be equipped with not just System 1, but also System 2. The great Prussian philosopher Immanuel Kant wrote, in his Critique of Practical Reason, two things fill the mind with ever new and increasing admiration and awe, the more often and steadily we reflect upon them. The starry heavens above me and the moral law within me. Close quote. Admiring the starry heavens is an intuitive judgment. The System 1 Adam, once well trained to reliably predict when to express admiration and awe for the natural environment, can do that. But the System 1 Adam who can appreciate the starry heavens would not be able to reliably see moral law. Because of the hybrid system, both System 1 and System 2, humans can identify and admire the moral rules within us. If machines are truly like us, they must be able to see not just the stars in the heaven, but also the starry moral laws.
Okay, I think we're all back.
Yep.
Okay, so we are now open for questions, and I encourage you to put them in the Q&A, and I will moderate. I guess I will start with some questions of my own. Taiwan has sort of provoked us to think about what is the human and what is the human in relation to the machine. And I want to use that as a jumping off point because I think both Katina and Michele, in terms of what can we do after our critique to make sure that AI systems are more just, humane, take us into the light, you both suggested that we need more humans in the loop, I think. So Katina, you talked about, more cross-checking, and Michele, you also talked, and this, I want to start with you, Michele. You talked about the opacity of these systems and the need for more human judgment in terms of ensuring that they are non-discriminatory, but also more humans to mediate between those who are affected by the algorithmic systems and those who create them, to make them more transparent and more sort of tractable to the people who are acted upon. So my question to you, Michele, is, I think sometimes when I've talked about this, people have said, oh, but these systems are designed to overcome human bias, and sort of, it's dangerous to have too much humans in the loop because then you undo some of both the efficiency, but also some of the justice that's designed, ideally designed into these systems. So I just wondered if you could comment on sort of the pros and cons of humans in the loop and where in the loop you think they should go.
Sure, thank you for that great question. It's important for people who put so much faith in computers, as you mentioned, to understand that there was a human in that loop too. It's two human systems. One is masked behind computer code, and one is interactive with, potentially more opportunities to exercise discretion and assess credibility and things that we can do interpersonally. But it's not like a computer versus a person. It's two different forms of human-generated decision-making. And yet that bias that you mentioned is something I've definitely encountered in our practice, appearing, for instance, before administrative law judges in public benefits cases, who, when the state has presented an algorithmic determination that's disadvantageous to my client, is just like, but the computer said it has to be right. And so while I think we need humans in the loop, they need to be informed humans who attended all three talks today and the entire Critical AI series, and who understand how algorithms are built and how they can fail us. Judges, policymakers, they don't need to learn how to code computers, but they need to understand where these algorithms are being used and how they're constructed. So yes, I think we have to retain human judgment as a layer of both design, as Katina mentioned, and monitoring, but it has to be informed humans in the loop, because otherwise we just come up again and again against automation bias and just an over tendency to defer to an algorithmic outcome. Oops, I think you're still on mute.
Sorry, Katina, do you want to speak to that as well?
Yes, firstly, I'm just so honored to be on this panel with Michele and Taiwan. And Taiwan, what a contrast. Here I was at the beach, surrounded by water and nature, and then we hear the bot. And it sort of had a visceral, emotive response in me. And I thought, I never want to become like Watson. I want to retain my humanity, and this anthropomorphization of this amazing human faculty that you were showing us in the form of this voice. So thank you for the provocation, Taiwan. And Michele, so much of what you're saying is affecting real people. It's asymmetric. You know, it may not happen to everyone, but it happens. And in Australia's context, as I noted in my video, 470,000 people out of 25 million were affected. Very asymmetric, but not like one in like 1 million, you know, it was 500,000 out of 25 million. And a lot of these people ended up paying without questioning, thinking, oh no, I've made a mistake. I don't want the government taxation office after me. So once we've lost our faith in the system and we can't explain it, and we don't know what's going on, we know a lot of people are worried. And this is one of the biggest problems I feel in the development and design and deployment of systems, whether they're AI or whatever, that the user is at arm's length. It's somebody over there, but we don't realize we as the builders, and I'm talking as myself as a computer scientist, actually will become the prey. We are the victims of our own creation. And this is an incredible thing to think about. So as we're developing these systems, human in the loop is necessary as far as I'm concerned for those cross checks and balances, all the reasons you stated, Michele. And I think Taiwan, all those things that you were alluding to with your division of logic and statistical, the system 2 and 1, if I go backwards, and this notion of people relying on machine learning, but really, weren't we doing AI in the 1960s? A lot of physicists I talk to say, yes, we were. We were doing it long before we claimed machine learning. And so are we just ending up, I feel, in an endless loop with the machine learning? A lot of computer scientists reject machine learning altogether. But I think here, Taiwan, you're sort of bridging and saying we can take the good things of both sort of approaches and bring them together for that ultimate thing.
Thank you. Taiwan, I want to come to you next. We have a really good question from David Squires that's also alluding back to the keynote of last week. So he asks, I wonder to what extent the two theories of mind rely on normative cognition. What happens if we introduce non-normative forms of cognition associated with cognitive disability, for instance? And then it goes on to say, I'm thinking in part about last week's talk, which suggested that AI studies have not adequately assimilated lessons from disability studies.
I'm not really sure whether I correctly understood the question here, but let me try. So the two theories of mind are not themselves normative or non-normative. So they are just one way to explain how human brain works. And largely there are two, as I suggested, through the voice of IBM Watson, computationalism and connectionism. And connectionism says that brain works as if it is statistics. So I call machine learning as automated statistics, and it's a correlation machine. And then the other theory, which is computationalism, argues that human mind works like a computer. So it's not like statistics, it likes like a logic. If P then Q, not Q then P, and something like that. And so one advantage of the logic-based system is the system can learn rules, like do not infringe a certain kind of human rights, etc., whatever the human rights are determined. However, the way correlation machine works has nothing to do with the rules. It's just all the fragmented ideas and associations. And just think about it, how humans and societies regulate human behaviors, mostly with rules. The law is a set of rules. Accounting regulations, generally accepted accounting practice are all rules. So we need some rules. And one bad thing that is happening is the industry is now losing the logic-based AI's power to learn and use. I'm sorry, my dog is just does not want to leave me alone. So that is one thing. The second thing is that now how so what I really don't understand clearly is about what it means to have a cognitive function with disabilities. And if I don't clear the Alan. Can you?
Yeah, well, let me try to relate the question to your system. So if we imagine a sort of bottoms up set of correlations, what is the universe of sort of examples that we're drawing from? And are we drawing from, is the community of sort of norms that we're drawing the inferences from, is that sort of, you know, the average community, the normative community, or are we capable of developing sort of AIs that are different, that reflect the differences of multiple communities? And I think you could ask the same thing, and we can get to Rachel Saunders has some interesting questions about sort of, if we imagine a rule-based system, whose rules, which norms are we instantiating in the AI?
I think that is a question, and largely defined human values should be taught to AI. However, they are defined, but you know, as Michele and Katina presented, we have to engage with stakeholders, and we have to represent values from diverse groups, so that but the thing I wanted to say was that whatever value systems, whatever rules we want to teach to AI, machine learning cannot do that. Machine learning itself cannot do that. So that is maybe a separate question. And in my research, I usually try to teach widely accepted ethical theory already developed and discussed by philosophers over the last decades to AI.
Thank you. So this question, I think we'll start with Michele, and this is following up on the human in the loop. And Katina, if you want to chime in here too, you might have some ideas. So the question is from Tawfiq Amari. And Tawfiq asks, given the lack of interpretability of many of the models currently in use, especially neural networks, how can we better provide a bridge of humans in the loop to be more informed about how the algorithms are introducing their own biases? So I guess, how do we get those informed humans, given the fact that even the creators of these algorithms and algorithmic systems can't really explain how they work?
Right. And obviously explicability can vary depending on the type of algorithmic system that's used, as Taewon pointed out. But even if the black box itself is not easily explainable, I feel as a lawyer, I'm still entitled to someone explaining to me in plain English, what is the goal of this? What are the factors that it is weighing? What sort of weight does it give to the factors? What are the outcomes that it's being programmed to deliver? So even without explicability around the black box operations, there is a lot of explaining that is still possible, human to human. And if those questions can't be answered, then I don't believe the tool should be used. I mean, humans aren't guinea pigs to experiment with AI. So if you can't answer my basic normal list of interrogatories, like what was it programmed to do? What are the factors? What data is it trained on, and so forth, then we shouldn't be using it. That's my opinion.
Katina, did you?
Yeah, I want to really hesitate and think there. I'm thinking along the lines of Michele. We've got to be very careful about unleashing systems that don't do what they say they do. So if we don't know what the system's going to do, why are we building it? If we have no idea, that we unleash something and we are not even in control of the training data sets that it's engaging with, what are we doing? And why? I think it's very easy to jump on a bandwagon and say, neural nets, and then reinforcement learning, and all of these different algorithmic approaches to AI. But why? What's the rush? What are we doing? What's the outcome? And we've tried, has it helped us? So is it a hype bubble that we're going to say, we should leave it alone? And then we look at AI in the context of autonomous systems, and then it gets even worse. When there is a human in the loop, at least there is some, oh, look, there's a risk here, or it's affected the human in this way. But if it's machine to machine and we are not knowing what the subsystems are doing and the ripple effect in the bigger socio-technical system, why are we doing this? I mean, it's correct that what Michele is saying, if we can't explain it, don't have it. But I'm even going to say one step behind. What are we doing? What is this rush to go AI? Why are we even thinking about it? And when we have no definite conclusion at the end of it, what's the point?
I would just add here in the US, we talk a lot about how to better regulate these systems. And Ellen's work is really important in that, about transparency and accountability, but we need to be engaging more in discussions along the line of what Katina is talking about. It's just acts of refusal. Where should this just not be used at all? Because there's no scenario in which the pros outweigh the cons. Those discussions are happening in the US around facial recognition technology. But we need to sort of expand our notion of where should this just not be happening at all. There's no amount of regulation that will make it acceptable in terms of values, as Taewon points out, or human rights norms, or anything like that.
So I want to raise a question about this, and this is open for anybody, because we do have this movement of prohibition around facial recognition. And at the same time, we have these sort of emergent emergency situations, right? Where we've got COVID, we've got, increasing threat levels of cyber attack. And one can imagine, and people sort of, have talked about the cyber attack situation being kind of a rolling 9/11, where we're going to start seeing rapid changes to our surveillance environment, because people are not going to tolerate, people are going to want sensor networks that really monitor their whole sort of cyber physical environment to ensure that the water sources are safe and that the grid is not attacked, et cetera. And at the same time, we've got these prohibitionatory or prohibition movements. And so, if we just take COVID, we're starting to see, a lot of tolerance, right, for algorithmic systems to distribute the vaccine. I suspect that we will start to see a lot of tolerance for tracking of vaccinations, and then the use of certificates, in a sense, along the lines of the systems, Michele, that you were describing, that create permission structures and punishment structures. And so I guess my question is, how successful do you think, fencing around technologies is going to be when people feel that they're in an emergency situation? And in a way, it responds, Katina, to the question of what's the rush. Sometimes people feel like there is a rush and they're willing to accept privacy intrusions and also the risks of algorithmic injustice in order to take care of a risk they see as urgent. So I guess my question is just, do you have any reactions to that? Are there ways that are there governance mechanisms that we can use to sort of tie ourselves to the mast so that we don't, we're not able to implement systems when we're very tempted to do it?
Let me try. So let's think about this question in terms of the interpretability problem. So regulators want to take a look at the internal workings of the black boxes, but the black boxes is not explainable. So for instance, SEC now wants to take a look at the internal workings of the machine learning used in algorithmic stock trading. But there's some problem there, and there must be some development to develop explainable AI. However, explainability is not always really necessary, I think. And think about the use of AI in some emergency, for instance, medical context. And there's trade-off actually between explainability and predictability, and patients may have some best interest in having an AI system that has higher predictability rather than have an AI that has suboptimal predictability but with explainability. So think about aspirin. We do not know exactly why aspirin works for this type of disease and that type of disease, but it is end-to-end system. Once you take it without any serious side effects and the outcome is good, then you can take it. So if the circumstances is similar to that, then without explainability, maybe in some limited scopes of activities, black box technologies can be used if there is a guarantee that there is no serious side effects. But still, there are many cases that where interpretability or explainability is very important. Without explainability, what I'm saying is without explainability, there is no good way to regulate the problem. So for instance, in the finance sector, when you apply for a loan and your application has been rejected, then there is a law that requires finance companies to give you explanation why your application has been rejected. Then you have to have an explainable AI system. And actually there was a case that Goldman Sachs and Apple jointly developed an Apple Card. And then some people applied for that, and then there was some problem rejected, or maybe there was some problem, but the service center says that actually it is a black box, so we don't know why your case has been rejected, and that is a problem.
That was a problem of gender bias. Within married couples, men had credit limits 10 times higher than their wives from affluent families, and they never could get an explanation why the algorithm was favoring men so much more than women. So that's a great example. Yes, I believe the state of New York is investigating that. But again, are they going to hit the black box problem? Are they going to hit the trade secrecy type problems that Professor Goodman has written about? Where do we go next? So.
Okay.
Could I add, Ellen, just quickly? It has a lot to do with auditability. Paper trails could be audited. We're now in systems that can't be audited. What is going actually on with stock market? Why are the rich getting richer? What kinds of maneuvers are being pulled in the algorithms? And we should not really be thinking there's nothing that's going on here. Of course, there's lots of things going on. We just don't know about them. Ignorance is bliss, perhaps. The other thing I want to emphasize here is ubervalence. If you've got all this information, and then you're making predictions on this, of course, it's going to lend itself to misrepresentation, information manipulation, okay, and misinformation. And then we're worrying about fake news, and we're worrying about disinformation on social media. Of course, we're going to have that. If we've got all this information about identification, about location, about condition, we're going to say, oh, there's an app for that. Look at the COVID safe apps, even the Google and Apple app that was supposed to dismiss all the woes of the government-centric innovation. And the other thing is that they didn't work. The prediction algorithms built by Stanford University and users who pulled their data to say, look, let me see if I'm symptomatic. Let me see if I'm carrying those COVID-related symptoms, and then I can self-quarantine faster than going out there and giving everyone the virus. But what about those people that were asymptomatic? It's false. It's a false sense of security in technology and AI. I'm not saying technology doesn't work, but the COVID apps were a complete disaster. None of them worked. Contact tracing didn't work. Location-based geofencing didn't work. All of these things, but we have these purported stories that drones surveilling people are gonna solve the crisis. That placing anklet bracelets on people as if we have GPS surveillance everywhere, and all of these other technologies like automated number plate recognition that does rely additionally on AI for movement data going in a particular direction at a particular speed. Was it non-essential travel? I mean, are we fooling ourselves? I'm going back to what actually does work in educating the populace, in raising awareness, in doing the hard work. We're trying to circumvent the hard work with AI, but I think we may end up starting to door knock and say, do you know you should be wearing a mask? Do you know it helps you in this way? So we're trying to get AI to do what was done previously by the coordination of humans effectively. And we're going, we can do this with AI. There's too many people in the world. We're actually local is the solution.
Thank you. I really like that. Local is the solution. Here's an interesting question from Jeff Robbins. In the research in the disciplines courses, he writes that I teach in the writing program at Rutgers. I ask students who generally at the conclusion of their papers make recommendations to discuss the barriers, the hurdles that stand in the way of real world sustainable realization of their recommendations. So I would like to ask the speakers, he says, the same question. What's standing in the way of your real world realization of your recommendations? A few of the barriers I have proposed is the deep-seated tendency to take paths of least effort, the Matthew effect, as those who have shall be given, and those who have not will lose even that which they have. Our predisposition inherited from our hunter-gatherer ancestors have been driven out of whack in our technology-transformed world. So that's a question for anybody. What stands in the way, do you think, of realizing your proposed recommendations?
I'll say from my perspective, with my focus on economic justice, is this is about powerful institutions benefiting from individual data or the ability to control people around their data. And so this is like a tale as old as time, that powerful entities have the money and the lobbying power and the influence that my clients don't have. Political scientists know that legislators are directly responsive to affluent constituents and don't care at all about the views of their less affluent constituents. So for me, because a lot of my proposals are around lawmaking, it's just that the power imbalance in American politics is a barrier. But of course, there's so many other barriers that we've all alluded to today, some of which is just a lack of public urgency around these issues through lack of public knowledge, lack of public information. As you noted, in the name of the pandemic, all sorts of workplace surveillance has been expanded, school surveillance has been expanded, and that becomes normalized. And then we come out of the pandemic with even much broader technological frameworks of surveillance, and it becomes normalized, and then it just expands and expands and expands. And just the political interest, the financial interest in the country that's favorable to them. And it's not that there's no hope, because of course, we've seen incredible grassroots and social movements, particularly in the last year, but it takes a lot of concerted organizing and attention to these issues.
Thank you. Anyone else want to take that?
Thank you for the question. And I think there is no good solution, no easy solution. So you know, there's no really good way unless much more investment. I mean, money is really directed to not just engineers and computer scientists, but also someone like all the panelists here and the organizers here, some movement like critical AI. And a lot more efforts must be done to answer many of the questions. For instance, the question about disabilities, whose values and what rules, and also there are some things we can use right away. There are some softwares that can make your deep learning to be explainable to some extent. Align and SHAP, AIME and SHAP, not 100% good, and because the deep learning is itself not causal system, there is no counterfactual reasoning, because explanation actually assumes counterfactual reasoning. So explainable deep learning is actually oxymoron. So, you know, people like Judy Appler and someone mentioned here are trying to develop some kind of hybrid machine that has good parts of the machine learning, deep learning, and also good parts of the classical system. And IBM Watson is doing that too. And so unless we take another step, totally another step. And much of the problems we are seeing won't be really resolved. I think so. And but one thing that I tell my students is people need to understand how deep learning is trained. What deep learning really is, and the gap between ordinary people's perception of deep learning and computer scientists and professors' perception of deep learning is totally different. Most of us, we think that deep learning is just crap. It's dumb. But most people in ordinary setting think that that's computer that must be trustworthy and perfect. So so they need to understand what I suggest is, there must be some easy way to understand how deep learning system is trained. It's like a domesticated pet or animal.
Yeah. So I know Lauren Goodlad has some questions that she's going to read herself, but before we get there, I just want to ask this one question for Katina, and this is from El Frere. And El Frere asks, if we don't release an AI system with all its inherent flaws, how will we learn from the mistakes or gaps? And I think this connects to your point about pilots. And so maybe you could talk about that.
Sure. I think we've already seen so many examples of where AI has gone haywire. Do we need any more?
Well, I think the question is, isn't there some value to doing a test run of AI so that we can learn where it's going haywire so that we can correct it? Don't we need to sometimes release it in order to detect its flaws?
Yes, and I think I'm saying the same thing again. It's of course, context is everything. What kind of AI are we talking about? AI is not a single technology. Let's not be fooled here. What's your definition of AI? And I'm not saying this to the person asking the question, I'm posing this back to the audience. What are we saying when we're saying AI? Does it include this? Oh, it's all AI. We're in this hype bubble. Oh, it's AI. Last week it was big data. The week before that it was something else. It was analytics. The week before that it was something else. This is just hype cycles. And if we want to say, what is AI? Let's call it emerging technology converging. Let's look at grabbing this and this component and this, and we can say we're implementing it using this particular algorithmic approach. Okay, then we can have another discussion. But when we're seeing this recurring pattern of AI, the thing that's going to solve all the problems actually not working, we've got to ask ourselves, hang on a second, let's slow down here. And what I'm talking about here is, the answer I would have given to the previous question, which is deliberation. It's not move fast and break things. It's not, we can do this on the cheap. Don't worry about embedding privacy and security by design in anything. Don't worry about asking users. Don't worry about piloting to at least 20,000 people in a city to see what happens. And I don't want to be a living lab. I'm gonna stress this. I do not want to personally participate as a member of a living lab. I'm not a rat. I don't care if it's an open environment. I don't care what context it is. I'm not a living lab. And I think, again, it goes back to deliberation, taking time, spending the money. None of this, I'm thrashing in a reactive mode. Oh my God, there's a pandemic. Yeah, oh my God, there's a pandemic. And what do we know about pandemics? Manual contact tracing works. We know that masks work, that are standard masks that are approved. We know that hand washing reduces all pandemic viruses by 30%. I've talked to members of the Cochrane collaboration. We know there are people who are asymptomatic who could be spreading the virus. Okay, let's go back to the basics. Low fidelity technology versus high fidelity technology. And it's not even about tech at the beginning. It's about what's the problem? How is this pandemic behaving? Let's study the behavior of the pandemic and how it would simulate it. I'm not saying don't simulate it. I'm not saying don't use AI to try and mathematically understand what's going on, even statistically understand what's going on with populations. We've got to do all of this, right? The high fidelity solution I've been waiting for is the vaccine. It's here now. We take it, right? Low fidelity could be the manual contact tracing, low risk kinds of approaches that have worked for the last 200 years. It's just the population is denser these days and much bigger than it was 100 or 200 years ago. So I want to go back to public interest technology, deliberation, proper design mechanisms, consultation, and answering Ellen's previous question from Jeff Robbins. whom I adore, one of the problems is the social fabric of society is breaking down. That's where it starts, not with tech. I don't want to even talk about tech today. I know I'm talking about critical AI. I'm talking about the social fabric of the world is disintegrating. We're unthreading, where our fabric is loosely somehow coming undone. I don't know why. There are many potential reasons why this is happening, but I would say when local communities band together, then we can go at scale. As we mentioned, values before, cultures, languages, different markets and backgrounds, different things that people are worried about in terms of stigmatization, ethnicity, religious beliefs, blah, blah, blah. The list goes on and on. Age, we know all what they are. But I want to center on the social fabric as being the way that perhaps technology can respond to the needs of the people. So we don't just go to people, what do you need? We look, we observe, what do we need? We all know we need to mobilize right now to come back to the world because we miss each other. But that social fabric is, I think, what's going to spur on better technology, investing the money in the proper processes, not saying, as we did in Australia, $65 million for the COVID Safe app, then we can get going, Australians. Actually, it was money that was spent going down the toilet. Forgive me for the expression. That money was burnt. Nobody benefited from that. People got false bugged apps that said, oh, go and see your GP because you've got COVID. You came into contact with COVID. What? You know, how can we deploy these technologies and then go to the government, go to the people and say, it's working, everyone, it's working. And don't believe that academic or that academic because they're liars. The app is working, please download it. No, we acknowledge that we have limitations. We acknowledge we can't get these apps to do what we want them to do. And we invest in people, in humans. You know, this is the response. We invest in a societal approach, a coordinated approach that takes money and time, not this move fast and break things business. That's never going to solve our problems. Systemic change is not products, it's processes. Processes change the world. These shiny apps do not change the world. They can enhance our world. Of course, I have 20 of these, right? It's about processes.
I would just add to all that brilliance that when we talk about learning through experimentation, more often than not, the people experimented on are poor, marginalized, socially excluded people and minorities. So we have to be really conscious, like this whole learning through doing, someone pays the price and it's socially excluded people. So I liked what Katina was talking about earlier today about doing piloting these tools before you deploy them at vast scale. It's absolutely essential.
Thank you. Lauren, do you want to ask your questions?
Sure, thank you, everyone. So my question was originally formulated for the entire panel. I'll update it because we've already heard part of the answers. Each of you has been saying in various ways to the fascinating questions that people have been asking, how difficult it is for us to accurately convey what computer generated, or perhaps we should say computer assisted artificial intelligence actually is. And among many other things, Katina pointed out in her video that our experience as humans is deeply rooted. She said we have to remember where our feet are planted. And, you know, as environmentalists and eco-critical thinkers, we're trying to think in more planetary ways now and to level our awareness to not always think about human first. And clearly that's extremely important for us to cease being instrumentalists who simply take the environment for granted. But by the same token, we're now challenged to not bracket out the way we continue to live and learn through our bodies and make decisions that way. So my question for you, Katina, is simply, you know, where can we fit the body into critical AI that allows us to still be good environmental thinkers? Michele, a different version of this question for you. You're rightly emphasizing that human computer scientists are still in the loop. And It's not only the case, though, that the human impact is about programmers designing algorithms, which they sometimes can explain and sometimes can't, as in the whole question of the black box. But it's also the case, as you point out, that data is itself produced relationally. This is a point that Sibelo Malambi also makes in the article that we read about Ubuntu. So the data that's being unaccountably accumulated and then mined for predictive learning in the way that Michele describes, they're not in any sense reliable or accurate, still less ethical, and yet they are still quite systemic. We need to bear in mind that they're still reflective of a very large thing. We can't write them off. How do we deal with the fact that we're now in the grips of this data-centric predictive reasoning that, in a sense, bespeaks the system that we're already in, without simply pointing to the human presence of this programmer or even this company or set of investors in a technology? Finally, my question for Taewon, which follows from the latter, I think you're essentially showing us that McEwen's novel, for all its being so interesting, can be misleading, since nobody knows how to build any AI with human-like integration of correlation at massive scale, which is something that human beings simply don't do. We are not probabilistic, stochastic thinkers with access to an entire internet to scrape, and we're not even good Kantians most of the time. So what my question for you is that, you know, Turing's notion of AI as imitation, which is really for Turing more to do with how humans could be fooled under very specific circumstances, which exclude the body once again, isn't really about suggesting that the AIs in question would learn by imitating us. Is it perhaps the case that what we're seeing is not AI that is mimetic in the sense of imitating us, so much as we being asked to imitate stochastic models, to think more like machines, in other words? In other words, perhaps AI is not imitating us, but we're being asked to imitate them, to believe in a kind of human or superhuman intelligence that is more like the way machines think than like the way we do. Thank you.
We have about 4 minutes to answer those questions, so whoever wants to go first.
I will go first, otherwise I'll forget the question. I've shared my screen, and very quickly I will say to Lauren, yes, we have to find that balance. Here we have a polar bear in the Arctic who's wearing this GPS tag. Just envisage this. For sustainability, we're placing these belts around our beautiful wild polar bears. When I saw this scene on TV, the polar bear was going, rah! But then we want to tag the trees in the forest. We want to implant every tree and identify it. We want to go and do traceability through the whole food chain. And in the end, we want to stick implants in people too. This is a committee on radio frequency identification technologies, computer science and telecommunications, way back when, in 2004. So my real last message is there's a fine balance between tagging everything in the environment, tagging ourselves, having complete visibility, total visibility, and ending up not knowing anything more than what we began with. I think we've got to look within. It's not about quantifying and counting. It's about the inside, right? And so with the environment, do we need to stick tags on everything, or just do we look out there and go, oh my God, there are no forests left? So while we're busy quantifying, things are being depleted and the oxygen levels and nitrogen levels are changing in the atmosphere. Who cares about quantifying? Who cares about the AI when we're suffering here in an ecosystem? So we're blindly computational and statistical going, heck, this is the answer, the number to the 0.35789101000. Who cares? Can't we see what's happening to our society? Can't we see there's a quarter of children suffering from mental health disorders? Can't we see this? We need to quantify everything. We just have to look at our households, ladies and gentlemen. And that's my last point. Forget the AI, start looking at each other.
Thank you.
So thank you, Lauren, for that question. Yes, data-centric technologies are here to stay. And I think the answer to making them empower people rather than oppressing people is that there is no single answer. It's going to take multi-pronged approaches. And that's why I so admire critical AI and your initiative here at Rutgers, because it's going to be interdisciplinary among multiple professions. Just from a legal perspective, it's not just lawsuits and litigation, it's law reform, it's community advocacy, it's grassroots organizing. And we can multiply that out by all the disciplines that need to come at the table. So there's no one answer, but there's many answers of us all working collectively.
I think that's a beautiful place to end this. Lauren, would you like to have the last word? Lauren, you're muted.
Please let Taiwan have the last word.
Okay.
So the question, I like the question, and in the novel, Miranda's father at some point thought that the owner of Android, Charlie, was the Android. So because actually there is a research showing that humans reinforce AI, that also reinforces humans. So once the training data is bad, that reinforces AI to be a bad manner, that reinforces human beings further. So that is some vicious circular. And we need to cut in the vicious circle. And how can we best develop AI system that helps human beings to use system 2 as well as system 1? That's a question. We need to pay more attention to the question. Thank you.
Thank you so much. And I want to apologize on behalf of myself and Ellen that not all of you were able to hear your questions answered. Please save them. This is only the beginning of a discussion that will be ongoing. I will now pass back to Ellen, who will thank our panelists on all of our behalf.
Thank you so much, Michele, Katina, and Taiwan. Really stimulating. Thanks for joining us, everybody.
Thank you. Thanks for having us.
Thank you so much, Ellen, Lauren, and the team. Thank you, Taiwan. Thank you, Michele. Bye.
Be well.